Hello and welcome to this Bricsys Digital Summit breakout session. This session for today is about BricsCAD Pro. My name is Fredrik Gundersen. I act as a product owner within Bricsys, and I will be taking you through this session, mainly focusing on 3D modeling and design flexibility within BricsCAD. So let us not waste any time and get started. Traditionally, 2D drafting has been used for detailing designs. However, in more recent years, 3D modeling has started to be adopted for the same purpose. Looking at it this way, both methods have been used for the same goal in mind, solving design problems. While 2D drafting has its own benefits, 3D modeling offers a new set of benefits. 3D modeling allows the user to create realistic representations of the finished components, meaning better visualization. As a result, your 3D designs are even more effective at communicating the intent of the design. All this should be done while offering you the control and precision you require over your design, but still without imposing restrictions to your ideal results. 3D modeling tools have traditionally offered two distinct approaches. The first being direct modeling, where geometry can be moved dynamically and freely to create a shape. And the second approach being more parametric and history-based modeling, where geometry is fully constrained by dimensions and features are controlled by a hierarchical feature tree. The direct modeling approach offers a high level of flexibility, enabling models to be created quickly, whereas the history-based approach provides a great degree of accuracy and control, especially when fast changes or updates are needed later in the design process. The two approaches therefore have their plus points, but also their downsides, meaning that choosing one, you of course gain all its benefits, but also all its downsides. For example, history-based modeling can be experienced as a very rigid system, where a specific workflow and method is preferred, and if it is not followed, it can result in history tree corruptions, causing the modeler to go back through the saved features, analyzing where the corruptions are so that they can be resolved. As a result, certain modelers require extensive experience or training to use efficiently. BricsCAD, however, is not bound to feature trees or history logs, and rather uses a direct modeling approach, meaning that if you have a 3D solid, BricsCAD can work with this part as if it was made natively, the same way you would normally even if it is imported also, making the user free from history log corruptions and difficulties porting them, while still immediately getting the advantage of all of BricsCAD's modeling tools. With the 3D model, the user can still apply parametric intelligence within BricsCAD. This way we create a variational modeling approach, as we call it, combining positives from both direct modeling and history modeling. One way to create a parametric intelligence for your part, in this case of the demo, as you will see in this presentation, one way to create a parametric intelligence for your parts is in this demo, as you will see later in the presentation. So you will see that while we offer a direct modeling approach, we also support more advanced methods to create complex models, creating a truly variational approach, combining the best of both worlds. In this session, we will specifically look at an electric vehicle charger. We will have the base design to work with, but where you will see an update is truly needed for the design. And we will be listening to some new design guidelines and trends in this area. For example, some guidelines are to make the design more ergonomic, which we will look at to make the design more sleek, which requires essentially less cleaning and maintenance in the end. Ensuring the design has a good height and size for reaching all of the relevant equipment and functions. Also, making sure the design is safe, for example, that there are no sharp edges. Another guideline to follow is to offer all equipment needed for the process in one place. Some chargers actually require the user to bring their own charging cable. And lastly, it should also offer all clear information and instructions needed. So with that, let us jump into BricsCAD and we will start this example. As I mentioned, we can immediately see that this design is quite outdated and requires an update. We can see that it has an old and clunky payment terminal and screen on this unit. This will then be deleted, of course, and then later in the design phase, we can replace this with a fully digital screen with contactless payment, making it easy to clean and easy to use. Another thing we can see with this design is that it only offers a power output plug, meaning that the user needs to bring their own cable. So in the new design, we should redo this so that a cable is included with the unit. As for the general shape of the cabinet, we should make it more ergonomic, meaning fewer sharp angles. Also, we will make it a bit taller and wider while making it slimmer, so that it is at a more appropriate height. So with that said, we have plenty of things to do here, so we will get started. First, we isolate the body so that we can work on this on its own. Next, we can move the back wall to make the body slimmer. Right now, we selected each face, both inner and outer, to keep the wall thickness intact. As we will want to move several faces and several walls of the design, to avoid making this selection each time, we can introduce some parametric intelligence here. We can select the walls and create a rigid set. The rigid set will make the walls keep the current relationship between each other, meaning that now we can move only one face, but the other will stay along with it, keeping the same distance between them, which will essentially make the design process easier for us. Now, however, instead of controlling each wall and the width and the height by pushing and pulling, we can apply some more parametric intelligence. We can add a distance constraint in each of the directions where we can control the sizes with a number value. This way we can resize the body and we are sure of the exact dimensions at all times. Next, we can apply this same method to the door as well. Now that we have similar constraints between the two bodies, we can actually link these constraints together. This way we can make the final design share the same dimensions just by controlling one number value per direction. The last thing we can apply a parameter to here is the window, where we will make space for a screen to be introduced at a later stage. We can set the distance for the actual size of the window, and we can set them to control the positioning of the window. As we want this window to be centered on the door, we can use a formula expression to determine this position. Now that we have the position right, we can set a new size for the window using the parameters. With the resizing of the cabinet, we also need to update the base that it stands on. So with our direct modeling tools, we can easily resize it. To make the base a little more interesting, we can also make a slope on it that goes outwards. We can create these new cross sections for the base and use the loft tool to create the new design. Another issue that was faced with this design was that the rain would enter through the cracks of the door. In the new version, we will create a more suitable design to keep rain out of this design. So we can create some sort of roofing simply by extruding the top of the door upwards, then outwards. And by giving it an angle upwards. Now we need the body to fit with the roof, so we will use the same method to angle the body as well. Then finally, we can hollow it out on the inside to ensure that it is a thin-walled solid as the rest of the body and door is. Next, we will make the design more rounded. This is so that it is more ergonomic in case of persons colliding with it, to minimize injury or to decrease the chance of paint peeling from the body once paint has been applied. The body is nearly finished now. We only require a location to place the new charging plug and wire. For this, we have a predetermined hole pattern that we can insert and extrude to cut into the body. Next up, we want to make the mounting system for the new charging cable. As we had a predefined hole pattern to work with the body, we also have a predefined base sketch to match the hole pattern. With this sketch, we can extrude it normally and use direct modeling tools to create our design. However, in case this mounting structure is subject to undergo changes in the future, it would be helpful to work with an underlying sketch that controls its geometry, kind of like a history-based approach. Well, like I mentioned, BricsCAD combines the best from direct modeling and history-based modeling. So we do have such a feature when your geometry requires the precision of the more history-based approach. In the settings window, we can enable this option called sketch-based feature. So as you can see, now we can extrude this sketch, and the sketch is linked with the extrusion and is stored so that we can open it and edit it still. In this case, we added some constraints to the sketch. And after this update to the sketch, the solid is still associated and shares the parameters. So if we are to change the parameters in the mechanical browser now, we will see the changes be applied to the extruded solid as well. Let us continue working on this part and finish it with some direct modeling now. We can extrude upwards to create a body. And we will use some sketching to create some side profiles and front profiles and extrude it into a right shape. Like this, we have now modeled the rest of this component using sketching and direct modeling tools. But one thing remains before this can be used in the charger design, and that is the actual slot for the power outlet. Of course, this is typically a standardized geometry, so we have a special component to solve this. Here we can see this feature. This is a solid with a specific layer. The layer is called a subtraction layer. We have a library of parametric features, such as holes and slots, that use this layer as well. These Boolean features are used to insert onto 3D solids, and the volume of the feature will be subtracted from the part that is inserted onto. Now, this subtraction behavior is given by the special layer that I mentioned, the subtraction layer. But in addition to the library of these parts and features, you can also create your own custom designs to use with this layer. So in this case, one feature has been created to match the standardized electrical plug for this purpose of the car charger. We can now easily insert this onto the part we just modeled, and the accurate detail will be part of our component now. So now that it is finished, we can place it on the rest of the charger body. However, the goal was to also include a cable and a charging plug. So this has been prepared in advance for the sake of time, using the same modeling techniques as you have seen up until this point. And we can now apply this and place it on our model. Finally, now that the design has been specified and created, we have a grid of charger bodies that have been placed that still requires these electrical components. We can continue to manually place the parts as we just did, but in this case, this can take up a considerable amount of time and take up a lot of actions for the user. Therefore, with BricsCAD, we have a feature to help us in this process. It is called CopyGuided 3D and will allow us to easily copy the details from one part to another. This is a great tool for many occasions and will save you a lot of time while still ensuring accurate placement of the parts. As you can see, we can define what reference faces it will work with, so we can make sure exactly that it is placed how we want it. So now I am certain that we have copied all of these components as accurately as I placed the first one. And we have finished with this charger layout and with our charger design for this session. To conclude, BricsCAD takes a different and unique approach, combining the best of both worlds with the flexibility of direct modeling, where shapes can quickly be created early in the design process, which is brought together with the control enabled by applying parameters and constraints wherever they are needed. This offers designers a truly innovative approach, which can give them a huge degree of flexibility and enable quicker delivery of new and updated 3D designs. BricsCAD is also free from the restrictions imposed by a history-based approach, which often brings complexity, which forces designers to spend a lot of time managing the structure of the model, especially when things go wrong. Again, this provides yet another level of simplicity and flexibility. So if you saw value in today's session, please consider going to our website at bricsys.com to download a full BricsCAD trial to try this out for yourself today. Thank you very much for your attention.